Independence shouldn't end with injury, but for our community partner Brian Bocott, a car accident at 17 resulted in a C6 vertebrae spinal injury that left him partially quadriplegic with constant obstacles in performing basic tasks. Inspired by his resilience, we A Cubed designed DexTerra Grip, an assistive glove engineered to restore hand function and independence. I'm Tanisha and I'm here with Joana and Anika.
Brian faces a mix of daily challenges, but beyond mobility concerns, what he misses most is his passion for music. Before the accident, he was a guitarist who performs for friends and family. Now, Brian can no longer press down on guitar strings. Hearing his story, we knew we wanted to create a solution that restored both his mobility and ability to enjoy the things he loves.
We approach the glove not just as a mechanical tool, but as a bio-inspired extension of the user. DexTerra Grip offers proportional assistance through a network of force sensitive resistors placed at the fingertips. These sensors detect grip intent and relay that data to an Arduino Uno, which activates a servo motor mounted at the wrist.
The servo motor drives a tendon-based mechanism composed of fishing line routes across the fingers. As the motor turns, it tightens the fishing line, mirroring the natural function of tendons in the fingers, enabling smoother and controlled interactions. The fishing line has been added inside the glove on our most recent prototype to ensure a sleeker finish.
The glove is also breathable, lightweight, and sleek, engineered for extended use. From a production standpoint, DexTerra Grip costs $216.18 per unit, with a profit margin of $43.42. Each component was carefully selected to optimize performance without compromising on durability.
In a rapidly growing landscape, DexTerra Grip occupies a unique niche where competitors often lack proportional responsiveness. The potential impact of DexTerra Grip extends far beyond our community partner. Over 3.2 million people in the US suffer from arthritis, and 250,000 individuals live with muscular deterioration diseases. Our glove can assist not only quadriplegics, but also those with conditions like cerebral palsy, carpal tunnel syndrome, muscular dystrophy, and even workers who experience grip fatigue due to repetitive tasks.
Getting here wasn't simple. We went through 3 major design iterations, learning from each. Our first prototype used solenoids, but they pushed our fingers outwards. Our second used a 5-point servo motor, but the grip became inconsistent. Finally, we transitioned to a circular servo motor and reinforced the wrist with a 3D printed mount. This journey of trial and error brought us to our final design, which is both functional and ergonomic.
We're
30
now
seconds
focused on
left.
three key areas. First, refining our materials. Second, gathering feedback from a wider range of users. And finally, we're exploring mentorship and funding opportunities so we can scale production and form partnerships with rehab centers and assistive tech organizations.
At its core, DexTerra Grip is about empowerment. Everyone deserves the chance to perform daily tasks and pursue their passions without limitations. With your support, we can bring this innovation to the people who need it most. We're A Cubed, and we believe that strength in your hands brings freedom in your life. Thank you.
Thank you.
Okay, right on the dot. Thank you so much. Congratulations for your innovation, Dexterra Grip. So we'll move ahead with the question and answer. And Ade, can you begin?
Yeah, that's amazing presentation. So what the most challenges that you found when you running this project and how you overcome it?
Our biggest challenge is probably that our community partner lives in Washington, but we kind of just overcame it by practicing and like talking with him a lot about what he wants and like what he wanted us to focus on.
And another challenge we faced was how to make the tendon system strong enough to actually help the user without making sure it was like bulky that it got in the way. And we did that by making sure that the wrist mount was not in the way of him gripping items and by making sure the tendons were inside the glove instead of outside.
Really fascinating. Okay, next, Judge Brian.
So I'm again wonderful idea. Again, helping people. This is great. I was wondering about how did you guys come up with the ideas for the components that you wanted to use? I mean, that is miniature electronics and components that I don't think most high schoolers are exposed to. So I guess I'm wondering how did you guys get exposed to it? Where did that idea come from?
So we actually built this, like our first prototype in our engineering class at school, where we were given an Arduino and a breadboard, and through that we were able to come up with our initial prototype, and we've sort of built from that since then.
Nice. And
So really,
as part of that class, I was going to say, did they let you, like, was this a class idea, or you guys said you're given this stuff to learn on, and you came up with the idea and said, I'm going to do this to make it better for somebody.
In the
Yeah,
class, we like partner with somebody and then we kind of just work with him to see like what he wants. And then like we had the idea to come up with the glove and then like we created it as a group.
Yeah, we
Nice.
kind of like we have our community partner, like Joanna said, who's Brian, and we like talk to him and figure out what kind of problems he faces on a daily life, on his in his daily life, and solutions for different kind of problems and what solution we want to go forward with. And this was the solution that we thought could help him the most, and we ended up going with it.
Nice. Well, very good. Very
Thank
proud of
you.
yourselves.
Wonderful. This is the kind of learning activity that really makes sense. Thank you so much. Now, Katia.
Hello, thank you. This is an amazing idea. It's wonderful. My question is most about what was the most surprising thing you learned, like while working on the project?
I think the most surprising thing was how like all of our ideas came together and we were able to even produce this product because when we were first thinking of it, it was just like an abstract idea. So the fact that we were actually able to produce something that actually works and that we can build upon later was pretty surprising and good.
Yeah, and it was pretty cool to see how our like project and glove evolved from our initial like idea and brainstorming to like what it is now.
Yes. Congratulations. Thank you.
Congratulations again to our DexTerra group team. Now, maybe the students, you still have a minute that you maybe have a question for this team. Okay, so our students are quite shy. That's okay. I just wanted to really congratulate you for the job well done. I mean, all of the teams so far have given us products that really help out very specific needs, right? So I just wanted to ask if you have already tried to also test it with another disabled person.
Unfortunately, we haven't had the opportunity to test with a disabled person because, well, our community partner Brian lives in Washington and we live in California, and there wasn't a way for us to meet up. But I think with time, I'm hoping that we can actually meet up with him or someone else and try to test this out.
Okay, great. That's really the next step that would be amazing to see so that you would have better feedback on your innovation. So thank you so much for your team.